Over the banding, first Viton was applied, then the Limitrack, and this is showing the Limitrack being dried prior to doing any machine work. Once the Limitrack is dried, the first or initial cut is performed. Now they're only going to take down about 2 or 3 thousandths from the first cut. A brush is installed just to knock the shavings down.
Keeps it all contained right here.
We can already see that there's a problem where the commutator is a bit out of round.
2 to 3. I don't want to get too crazy with the diamond so don't wear the diamond.
There's a portion of it not being machined. Now the commutator is actually a banded comm, and it's installed on a fit back. There's only a couple of inches of interference fit back there that's holding that commutator on. This does not have a flange with bolts. This is just fitted on with an interference fit. Most commutators rely on a shrink fit to the armature shaft. Others include a flange mount and a slip fit with set screws. For shrink fit units, accurate bore sizes are critical for proper installation and operation. The proper amount of shrink fit is determined using the tables for ANSI, standard, force, and shrink fits, as found in the machinery's handbook. Commutators with quality insulation materials can be heated to 370 degrees Fahrenheit prior to installation. After the first cut, we can see that there's a lot of material that was not removed from the comm. The comm is a little bit offset from the center of the shaft. Using 2 dial indicators, we can see the amount of offset in the comm. We've got the top dial indicator is on the bearing journal, and there's just no run out in that dial indicator there, but the one below is on the inside of the steel barrel of the commutator, and it shows about almost 10 thousandths run out. Before performing the final cut on the comm, the machinist is removing or dressing up the side of the bars and removing the Limitrack on the side of the bar, as well as beveling and chamfering the corners of the bars. Next, we perform the final cut on the commutator. Once the commutators turn, the next step is going to be to undercut the slots. The undercut of the slot is done precisely with a machine. It's aligned parallel with the com bar, set up very precisely. Each slot is cut with a cutting tool that's slightly wider than the measured slot width. In this case, the slot width was 45 thousandths wide, and they're using a 50 thousandth cutting tool. The depth of the slot cut will be about 150% of the width of the slot. But in this case, they're used 10 thousandths over the width, so they're going to cut this depth about 60 thousandths. So the final cut of one slot is where that finger's pointing to. It looks rough now, but it'll be turned and stoned once all of them are cut. Once the bars are undercut, then a hand tool is drug across the corners of each bar, both sides, and the bars are beveled. Then the commutator will be stoned in both directions to smooth it out.